This video is lesson 11.1 extension 3. In this video we are going to watch a summary of the previous hydrogeological videos. We are going to be talking about the 10 common mistakes related to contour lines and groundwater flow direction lines. However, if you want a complete explanation about every mistake, I highly recommend to watch the previous videos. In that way, you are going to have a complete vision of this kind of common mistakes. Then let's go to see it.
1.
Contour lines and groundwater flow direction lines are not perpendicular. If the angle between the contour lines and the groundwater flow direction lines are different than 90 degrees, they are wrong.
These groundwater flow direction lines go against the gravity.
Now they are perpendicular.
Perfect! It takes the same time to do the things well.
Two.
Contour lines are not parallel.
I do not understand why someone drew contour lines like those.
Contour lines has to be always parallel, but not necessarily equidistant, as the hydraulic gradient can change.
Good job.
Three.
Crossing contour lines and run border of the contour lines. Groundwater contour lines represent different groundwater elevation, and it is not possible to have two different elevations at the same point. Be careful when you draw the border of the groundwater contour lines, to avoid a trend where the contour lines can cross each other. Remember to keep parallel contour lines in all their extension.
Why are these lines not good? They're only lines, right?
4.
Drawing areas of extraction and recharge due to the lack in knowledge of geological and hydrogeological conceptual model. In order to generate a cone of depression, you need a lot of energy. You can draw this surface if you can justify it. If there is no evidences of groundwater extraction, you cannot draw this kind of surface. If there is no geological evidences of a recharge area or injection of water, you are not going to have this kind of surface.
I would like to know if we have a pumping well at the investigated area.
Yes, I saw a bomb installed inside the well.
Five,
Unlikely groundwater contour lines for small sites and unrealistic groundwater flow direction maps. Be sincere, pragmatic, and realistic, and always ask yourself if these contour lines that are representing the surface of the groundwater table are technically possible. The smaller the site, the smaller variations at the groundwater elevation.
This is a good example of an unreal scenario.
six,
Interpolation extrapolation softwares for modeling the contour lines. Mistakenly think that a software is a hydrogeologist. The problem of using interpolation extrapolation software is that always you are going to get a result. It doesn't matter what numbers you are putting in. Always there is a result, good or wrong. These kind of softwares are very powerful and useful tools. However, in the wrong hands can create a big disaster. Before using a software for modeling, a professional has to validate the geology and hydrogeology. A professional can provide a solution without a software, but a software cannot provide a solution without a professional. It is evident that groundwater table is never going to represent the surface like that. Only the software can create results that face the physical laws.
The worst groundwater flow direction maps that I have never seen were those created with interpolation extrapolation softwares. Never use a software to interpolate contour lines if you do not understand the geology and hydrogeology of your site.
seven,
The location of the groundwater monitoring wells are not good to model the groundwater contour lines. There are a lot of examples where we can see bad location of the groundwater monitoring wells to model the groundwater contour lines. Let's see a few examples. Groundwater wells define a line and we need a plane. Very weak way to install groundwater wells, where we have two perpendicular lines. All groundwater monitoring wells together in a very small area that represents less than 20% of the site. Three groundwater monitoring wells is not enough to define the groundwater flow direction. However, in this case it's even worse because the wells make a triangle very weak. It is almost a line.
When you have to install groundwater monitoring wells, you have to think if those locations are good for modeling the groundwater contour lines. It is one of the most important points that have to be in your planning list. Remember to install the wells in a way that cover all the potential flow directions.
Eight.
3 groundwater monitoring wells is not enough to define the groundwater flow direction. In a Euclidean space of any number of dimensions, a plane is uniquely determined by any of the following 3 non-collinear points. Points not on a single line, a line and a point not on that line. 2 distinct but intersecting lines, 2 parallel lines. However, in hydrogeology, the space geology is more complex and the groundwater has a different behavior for each medium. Even for the same geological layer, the medium is anisotropic. This complexity makes it really difficult to define the direction of the groundwater with 3 wells. Sometimes 4 wells are also not enough. Then 5 wells is the minimum number of wells to create the first approach to the groundwater flow direction.
Not only it is very important the number of wells to define the groundwater contour lines, but also is very important the location of the wells to make possible the modelization.
Nine.
Geographic context means interpretation of the hydraulic gradient. When working in an area, it is very important to pay attention to the geographic context in order to get some information about your work area. If the groundwater wells in your site are penetrated a geological unit with high permeability, there are some chances to find pumping wells around your area. In this picture, we can see the potential wells we can find according to the line used. If you have pumping wells around your work area, be aware of the following. The local hydraulic gradient could be different of the regional hydraulic gradient. The local hydraulic gradient in the past was different. The local hydraulic gradient can change in the future. It is essential to identify the pumping wells because they can change the groundwater flow direction and spread the contamination horizontally and vertically. Now let's go to see an example where we have the same site but 2 different potential scenarios depending of the activity of a pumping well. In the first scenario, we have an area with a pumping well, but the pump inside the well is not working. This is the same scenario, same site, different scenario. Same area as before, but now the pump is inside the wall is working. Now the groundwater flow direction is totally opposite. When there is a contaminated site, it's important to monitor the contaminant concentration. And it's also very important to monitor the groundwater flow direction. As you know, it can change.
There is a new construction area 700 meters away of our contaminated site. The construction company are building a new underground tunnel and they are going to pump hundreds of cubic meters of groundwater.
We have to act fastly. We do not want the contaminant moves to the construction area. That is the worst scenario and it is going to triplicate the cost of the remediation.
Ten.
When taking measurements, be aware of your scale of work. If your area of work covers an extension bigger than 1 kilometer by 1 kilometer, you can afford to measure the water table in decimeters or centimeters. However, if your area of work is approximately 100 meters by 100 meters, you have to measure the water table in millimeters or centimeters. Only if you are sure there is a big hydraulic gradient. In small areas, the hydraulic gradient used to be lower, mostly in gravels and sand. And if you measure the water table in centimeters, you can miss the groundwater flow direction, as the values of the groundwater elevation are not going to be enough accurate for modeling the contour lines. In those small sites with high hydraulic conductivity, the water table is pretty flat, and the accuracy of the measurements it is essential to create a proper hydrogeological conceptual model. When working in a small site, it is a good habit to measure the water table in millimeters. In addition, it is very important to do the vertical survey in millimeters. Remember, every millimeter counts.
To measure in millimeters does not take any extra effort, and you will have the guarantee of a good job. The hydraulic gradient always follows the slope of the topography.
Fake guy. Groundwater is moving from the highest point to the lowest point. In other words, from the recharge area to the discharge area.